what makes your approach to cable design different from other people's?
Well, having played around with lots of cables which are already available and looked at the way they're designed and they're done, yes, you do have differences, and you do get some that they make the sound a little bit livelier or a little bit drier, a little bit full-bodied, etc. But that is not really the function of the cable. The cable should not be there effectively. You ideally want the output of one unit to be almost like soldered directly to the input of the other one. Now, for obvious reasons and logistics of home and thing, you put a flexible connection between the two. And the thought that this is just a conductor and therefore it conducts, I plug in the light bulb, it lights. There are degrees of lighting. We're talking here with an audio signal that has a very wide bandwidth, very large dynamic range, and the human brain and human ear that interprets the final result that you get as a sound. It has such an accurate way of realizing minute changes and minute detail that you require the best possible medium for this conductor to be used. You don't have an item going from A to B. You know, the signal doesn't travel from the end of the phono stage and go through a tunnel and comes out into the input of the preamplifier. What you have is that you are creating an electromagnetic wave, and it's the wave that travels, and at the other end excites the input of the other equipment to mimic what was happening at the source. You can put an analogy like if you had a channel of water, and you put a paddle on one end and moved it at a certain frequency, creating a wave of an amplitude and a frequency. You come at the other end and you put another paddle there, and that paddle start going up and down, very similar to the source. But that depends on what frequency and what amplitude you're using with a given size and shape of the trough. Now then, if you suddenly increase that frequency by 100 times or 1,000 times and reduce its amplitude suddenly, you may not create any wave going across, you may just splash water about. That's just purely because the nature of this medium that this wave is traveling through is not suitable to that frequency and that amplitude. And electromagnetic wave, just like any other wave, requires a medium to travel through. And the conductor that we're using is the nature of the conductor, the material that is used, the cross-sectional area that it has. How many conductors are they in contact with each other? Are they insulated from each other? What kind of plating they have, the thickness of the plating, and the twist on the cables and things will have an effect on what it prefers to conduct efficiently. And with the pulse range of cables, the main idea is to increase the ability of the conductors to represent this waveform at the other end, so they don't veer towards one set of parameters. They try and encompass as many areas of this wave, frequency, amplitude, and try and get this across to the other end, so that the input of the next equipment can then faithfully work like the source was working at the beginning. And because of this, we ended up with many different diameters of cables, different coatings on them, different numbers together, different twists. The insulation material that used, they can vary, the thicknesses can vary, and also we utilize some of the best equipment in the world to produce these. So it's not just, it's almost like blueprinted. So you have a very, very fine conductor. Some of the conductors we have, you can fit 4 of them in a human head. And you have several of these twisted, and inside a dielectric, the jacket, the plastic that you may call, which is Teflon type material. And we can even look on the machine exactly how centered it is relative to the outside. These create a very consistent impedance characteristics across the length of the cable and the processes that are used, etc. So the difference, or our approach, the way it varies is first the understanding of the waveform, that this is actually a waveform that requires a medium to travel through. We're not taking electrons from one end and dumping them at another end. It also requires several parameters on the materials that we're using, and at the same time the execution of that design. So you actually got an architecture, you know what you want to make, but can you actually make it? And these come together, and when they do, then you have a cable like, for example, the Pulse HB that's unlike any other interconnect or speaker cable or something, can bring any system to life.